Welcome back to the Hyperbolic Coding Chamber. We are back once again on a lovely and festive Friday. New Year's is coming up, and it is a time to reflect upon how we have been brutalized by the developers at LeetCode. So they've put us in the crucible, and we've spent our time battling the problems, battling the greatest brains of the 21st century. And what else can we do but be thankful for that? So, feeling pretty good about that. Fortunately, it's also Friday, so it's kind of like a double holiday. And that being said, shall we? No, but that being said, it is a Friday, so we're going to do a shorter session, right? The recovery day is truly just slightly less work than usual. So, it can't be helped, but it must be done. So we're going to do a slightly lower session, and fortunately we have a comment that's going to help us stall the session so that we don't have to jump right into it. And we have a legendary comment by an actually real person with a real name. Peter Peterson has returned. Hey, haven't been here in a while. Happy you kept going. I failed with LeetCode. No! Instead, I finished my first smaller project. Yo! Nah. Wish you the best for the new year and hope you achieve everything you want. Hey, man, you did not fail, brother. What did they say? What did the anime people say? They say you can't lose if you have your comrades. Or, all right, no, really though, I think there's definitely no failing. You achieved something that's just as cool, which is finishing the first smaller project. So, I think that is an incredible accomplishment. At the same time, I forgot what they say. I think they said the only time you give up is when you stop trying or something like that. And I think that's all there is to it. So, yeah, I don't think you failed at all, man. Because I consider every day not getting as far as I want to as failure, but that mindset can be really hard to get past, and it can be not helpful. So you gotta feel good about what you accomplished. And so I'm gonna also take my own advice and not be so hard on myself as well. We had an incredible run. There is no failure, only the next battle to look forward to. Much love, brother. (3D 2Y). Feel strong, man. Peter Peterson is a legendary human with an actually real name, by the way. And yeah, awesome comment, awesome human. We have nothing else really. I mean, it's kind of crazy that the year is ending. I feel like we should have something deeper to say, but at the same time, it's only been half a year of LeetCode. But I think things are definitely looking up. I feel that when I started like 190 days ago, this was really just a new way to train focus. And I definitely feel the effects of that focus. It almost feels like I wouldn't even say like the old person, but it almost feels like some of my older struggles. Like it was harder for me to stay focused on one thing for a longer period of time. Or to have, I think they call diffuse thinking, where you could set your mind on a topic and just think about it, but also allow it to wander without wandering into a whole nother sphere. And LeetCode really helped with that. So I could set my mind on a topic, like a problem, and then let it wander in a cage. And this kind of really helped in terms of other aspects too when I had to do that later on. So otherwise, you might end up in the thing where your mind is wandering and you just decide to do something else completely. So that happens to me, and it happens to me a lot. But the project has definitely helped. So it'd be interesting to see where our focus is in the future. And also, we're interesting to see where the grind will be, if we double our days. So it'll be actually a year. And yeah, it's pretty cool. I also sometimes wonder what it would have been like if we had did an hour of mediums every day, but we didn't do that. So we only did easies. So whether or not that's good or bad, only the future will tell. But yeah, a lot of people do a better split, and that's good. But I feel like we started on the easy, so we have to finish them now. Maybe I'm a completionist, but I'm not exactly certain. But yeah, it's just really cool to see, and the year's been pretty cool. I don't want to say I tend to be pretty optimistic, but at the same time, I don't want to jinx anything. So, or I don't want to overpromise or anything. But I felt like last year that something was coming, and we got to do a lot. So I'm hoping that next year, hopefully next year we'll be up next. So next year, I'm thinking we'll have done some pretty cool things. Maybe I'll release a couple of games. Who knows? Maybe we won't even be alive. That would also be crazy. But I was thinking about that the other day. I was like, what if I'm not even alive next year? And I thought, well, at least the videos will still be up. And I was like, that's kind of cool that I'll exist in this virtual space. Maybe they'll find a way to shove all of the words that I said into Chat GPT, and I'll become a model. I'll become an AI model. That would be pretty cool. But yeah, just random stuff. That being the case, we have a slightly shorter session to do today. And yeah, it'll be cool to see what happens if we keep up the pace. It's also interesting to think that I'm only doing I think the other thing, I didn't realize how far. I remember reading the Atomic Habits book, and I think James Clear was like, "Oh yeah, if you do something 1% a day in this amount of time, it'd be this good." And at the same time, the math checks out, but at the same time, also like, I don't know. But yeah, I was really surprised to see that. Obviously, there are people who have already done the entire LeetCode thing. There are legendary competitive programmers who can solve the whole of LeetCode in a month. But comparing myself to where we started, 1 hour a day, 1 hour a day takes you so far, which is just crazy to think about. And I saw that even in the game dev, we're doing which we're still working on, by the way, and hopefully there will be a video out either the end of this week or the beginning of next week for a more natural devlog style video. But it's just surprising how far a little bit of time can take you. And I guess maybe that's the illusion. I think we always use that little bit of time. That's how you get good at anything. But I think when you don't remember it, it's easier. Like when I first started playing League of Legends, I didn't really remember the beginning part from level 1 to 30, which took forever. All I remember is the now part where I'm stuck in silver, which is painful. So yeah, it's just really crazy to see. And it makes me think about the people who are doing more than that. The people who are doing 8 hours a day or 9 hours a day of grinding at something every single day. They're probably unstoppable. Also makes me think of Kim Jong-gi, who'd spent, RIP, but he spent darn near 10, 11 hours a day just drawing. The gap is insurmountable. So it's just crazy. So hopefully we'll get to a point where we can do something like that. That would be the end goal. If we could do something for 8 hours straight and actually do it, that would be crazy. I think then I would have been satisfied. But enough random thoughts. We have to do 30 minutes. And we're doing pretty good yesterday. Hopefully we get lucky and we continue to perform. And then we're going to set this up to do our classic 30-minute Fridays. That being said, if you enjoy something like this, you should join the Hyperbolic Coding Chamber Discord, where we're constantly exchanging resources, tips, tricks, and tools to LeetCode. As well as, we're going to have a talk about game theory and life led by a prominent member in our Discord community. So you should join for that as well. And then, we're just going to jump into today. So we have DI string match. Our permutation perm of n plus 1 integers of all the a permutation perm of n plus 1 integers of all the integers in the range 0 through n inclusive can be represented as a string s of length n, where s sub I is equal to I if permutation sub I is less than perm sub I plus 1, and s sub I equals d if perm sub I is greater than perm sub I plus 1. Given a string s, reconstruct the permutation perm and return it. If there are multiple valid permutations perm, return any of them. What does this mean? So we have a permutation perm of n plus 1 integers. So we're given a string, basically, in the range 0 through n. So a permutation of n plus 1 integers of all the integers in the range 0 through n inclusive, for example 3, can be represented as a string s of length n. S sub I is equal to I if perm sub I is less than I plus 1. And D if perm sub I is greater than perm sub I plus 1, which means decreasing. Given a string s, reconstruct the permutation perm and return it. If there are multiple valid permutations perm, return any of them. So we have increasing, decreasing, increasing, decreasing. So we have increasing, decreasing, increasing, decreasing. Okay. Then we have increasing, increasing, increasing. It looks like the real question being asked here is, given the integers in the range 0 through n, how can we create a permutation of them or a reordering of them such that it follows these rules? This one seems tough, actually. So that's why it has a lot of downvotes. Reconstruct the permutation perm and return it. If there are multiple valid permutations perm, return any of them. Permutation perm of n plus 1 integers of all the integers in the range 0 through n inclusive can be represented as a string s of length n, where s sub I is equal to I if perm sub I is less than perm sub I plus 1. I guess what we could do, well, how do we know the range of the numbers actually? I guess if we can literally choose any numbers, no, we have to choose the numbers in the range. So if we say we're going to use numbers 0 through 4, basically we're going to use the length of the string. Our permutation, our perm range is going to equal the length of the string the length of s plus 1. This would be our perm range, and it would basically be from 0 to n. So if we have a string of length 4, for example, length is going to have a length of 5, which is going to be a range. Oh no, actually. It's going to be length of s, because if we include 0, we should have 0, 1, 2, 3, 4, which would give us 5 elements. Then we have to figure out how to rearrange these n elements into an order that satisfies the above. I actually don't know how to do this, especially with s.length going up to 10 to the 5th. If it stopped at 12, then we could have figured out a way to do it. But the fact that it doesn't is pretty crazy. So let's see if maybe there's a way we can intuit a cheat code. If the first one is increasing, right? Maybe it makes sense to always choose the smallest number to increase. Right? So let's just say we would choose 0. Then we always start at 0 and we're increasing, right? So that would mean that the next number has to be increasing, so we choose 0 and 1. We choose 0 and 1, but now we need to decrease. We can't decrease now. So maybe it makes sense to always choose the middle point. Maybe if we always choose the middle point, we have space to go downwards when we need to. So instead of choosing 0 to start, maybe we could choose 0 to start. And then when we choose the second number, we can choose a middle point. So we could do something like 2. Now we're increasing. So we have 0, 2. Right now you want to decrease. We can go from 2 down to 1. Right, but we actually can't do anything else now. Actually we can. Now we can increase going to 4, and now we can decrease going to 3. So we increase 0 to 2, decrease 2 to 1, increase 1 to 3, decrease 3 to 4, and then we decrease with 3, like this. So basically, if we want to be able to always increase without thinking, we definitely want to choose the smallest number. And if we want to be able to always decrease, we have to choose the largest number. Decrease, always choose. If we choose the smallest number, it guarantees, well, maybe this is mutually exclusive. If we choose this, if we want to increase and we choose the smallest number, right, then we can't decrease because there's no number remaining. Similarly, if you want to decrease and we choose the largest number, then you can't increase. So kind of like we're back to where we started. Maybe. maybe we need to create a range. For example, our string has two i's and two d's in it. Oh my god, I never changed the screen. That's frustrating. So the problem is called di string match, permutation perm of n plus 1 integers of all the integers in the range 0 through n can be represented as a string s of length n, where s sub I equals I if perm sub I is less than perm sub I plus 1. And s sub I is equal to d if perm sub I is greater than perm sub I plus 1. Given a string s, reconstruct the permutation perm and return it. If there are multiple valid permutations perm, return any of them. So we're given the string IDID, which basically says that there's an I in the string because we're going from 0 to 4, and there's a D in the string because we're going from 4 to 1. So basically increasing, decreasing, increasing, decreasing. Here we have III, which is just saying that every pair, each I maps to a pair of elements, and it's just saying the relationship between those pairs are increasing. We have 3 to 2, 2 to 0, 0 to 1, DDI. What if we count how many I's and D's there are? We know that there are 2 I's and 2 D's. If our range goes from 0 to 4, we know that we need a range of numbers that we can both increase and decrease within. So what if we broke up the groups into something like this? This would be the D group. This would be the I group. Does that even make sense? If we had something like this, you have the I group and the D group. We have 1, 2, and 3, 4. Does this make any sense at all? Maybe it does a little bit. It gives us a way to split the numbers. So we know that we can always increase because our decreasing numbers are always less than our increasing numbers. If that's the case, we can always go from 1 to 3, right, to increase, and then to decrease, we can always go from 3 to 1, or 3 to 2, or 4 to 2. If we do it that way, then we can create any permutation we would like just by taking a number from these groups. So we guarantee the relationship of increasing and decreasing by splitting up the numbers into groups so that we can choose any arbitrary number. This could work, I think. So let's try it with the DDI example, right? The string they give us is DDI, and the number given is, array given is 3, 2, 0, 1 as the answer, right? But our start array given is actually 0, 1, 2, 3. We know this is our given start array because the string, each character in the string represents an array. Each character in the string represents a relationship between two numbers in the array. And we can pretty much extrapolate the length of the string to mean that there are 4 total length of the string plus 1 symbols to choose from because 0 is always zero is included as a symbol, and and we have the range 0 through n here. So if we broke the numbers into this group, let's just say we sort the numbers, and we'll just say that increasing is just going to be this 3 here, and then D is going to be all the other 2, the 1 and 2 here. So if we want to do D, right? If we wanted to do D, we actually have to pull. I guess decreasing would also include 0 here. So to do decreasing, we have to choose the largest number, which is 3, and then it does seem like, okay, I think there's a slight difference here. The difference being that the first character we work on, the first D or the I, makes us choose either the first element in the sorted list of numbers or the last element. And if we have something like D, it means we should choose 3 as our first element. If we choose 3 as our first element, now we'd like to decrease, we can choose... Wait, this doesn't make any sense. Right, I keep forgetting. A singular string means that we have to pull in a number from both groups. So if we get a I, it means to create an increasing, we have to take one from decreasing and one from increasing when we first start. After that, we can just choose one. So if we're going to do decreasing, we would take 3, emptying out this one here, and then we could take something like 2. Right, now you have to do another decreasing, so we can just take from decreasing again, which gives us 1, but it doesn't make any sense because now we need to do increasing, so we actually can't do 0 because that would be decreasing. So maybe what we really need to do is take 1 from decreasing, right, which is 3, 1 from decreasing, 1 from, no. 1 from decreasing, 1 from increasing, one from increasing, 1 from decreasing. Before we took 2, right? So we take 2 again, and then since we have another decreasing to prevent us not being able, but that doesn't make any sense because we put the other one. We could scratch this and just say that if it starts with a D, then D or an I automatically shrinks the pool. So if we start with a D and we include 3 as our last number, this would mean that 3 is already taken. If that's the case, then the actual range of numbers moves to D being 0, 1, and I being 2. Then we can restart with our answer. D starts with 3, and then we'd like to take from decreasing. To take from decreasing, we could take the next number, which is 1. So remove X, remove 1. Now I have another decreasing relationship we'd like to express. We can take the next decreasing, and then we can take the next increasing, which would be 2. first letter would take either the smallest or the largest D or I groups. So let's try what we just figured out with our original example. So we have IDID. Since it's I, it's going to take, D takes the largest number to start with. So I will take the smallest number, which is 0, which X's out 0. And then the remaining groups are split up like so, D and I. To represent an increasing thing here, we'd have to take 1 from decreasing, or since it starts with I, we take the smallest number. Then we can take 1 from increasing. So you could take 4 here. Now we'd like to represent decreasing, so we'll take 2. Now we'd like to represent increasing, so we'll take 3. And then decreasing, we'll take 1. 0, 4, 2, 3, 1 is increase. 0, 4 is increasing. 2, 3 is not decreasing. Oh, no, 4, 2 is decreasing. 2, 3 is increasing. And 3, 1 is decreasing. So I think this could work. Let's check our final one, which is I. And I do believe it seems to work for that as well. So we only have like 7 minutes to try and implement this, and we actually don't know if it's going to work. There's not many other combinations besides these 3. We have DDI, and I think it would also work for IDD. So the first thing we need to do is generate our range of numbers. Which would be an array of numbers. That for let I equals 0, I is less than or equal to, is it just called string s dot length I plus plus, we'll say nums dot push I. So we have the numbers now, right? And then we need to split them into groups, but first we need to create the output, which is also going to be an array of numbers. And if string sub 0, then we have to sort the numbers in ascending order. So we can split them into, actually they're already sorted in ascending order because that's the way the loop works. We'll say s sub 0 equals d. Then the first number that should go into it should be the largest number. So we'll say output dot push nums dot pop. Else, if it's not a d, it must be an I. So we'll push nums dot shift, which would be the first number. Right? Then the remaining numbers should be split into groups. Fortunately, since each letter represents 2 numbers, we should always be able to split the array evenly in half. Actually, no. Yeah, we should be able to. So it actually might make sense to split the groups first. So we'll actually try and split the groups first here. So for IDID, this would, oh no, it wouldn't represent, what am I saying? to split the groups in half. If we have 5 numbers, we split the groups in half. We take away 0, so we're actually fine. So when we have an even number, 3 here, we have 4 numbers. If we have something like this, 4 numbers, we take away 0. We need we need an extra decreasing we need an extra number in the decreasing group. So the one that gets the extra number so I have to count the num I and the num d. Let's say for letter of S, if letter equals D, let's say num D plus equal 1, else num I plus equal 1. And now to split the groups in half, the midway point will decide whether or not we seal or floor. So for let I is equal to, we'll say midpoint is going to be equal to s dot length over 2. Well, if num I is greater, if num D is greater than num I, right, then we'll say math dot seal s dot length over 2. Otherwise, we'll say math floor s dot length over 2. And then we'll say increasers. I guess in another way, the nums we could also just keep 2 pointers, and that would be another way to represent it. But for now, it'd just be simpler, just use another array. And then we'll start at I is equal to mid plus 1, and then I is less than nums dot length. These will actually be the decreasers, and then we'll just print constant.y increasers. And then I'm going to comment out this stuff right here and return an empty array just to see if we're splitting the arrays properly. So we have I did, we should have an even amount of both. So we have 0, 1. We're missing 2. I wonder with the case with 3, we probably have everything. I'm worried this is going to be a thing we have to handle some off by one case. Which would be very... which would not be flames. Oh, brother. If we'll change this to let. Yeah, we just need to finish this one, and I think we should be good, but I have to jet, unfortunately.